1. Earth's shape, an oblate spheroid. Earth, contrary to what most people think, is not a perfect sphere. Instead, it's an oblate spheroid, slightly flattened at the poles and bulging at the equator. This shape arises because of Earth's constant rotation. The centrifugal force generated by the spinning motion causes the equator to expand outward, creating the slight bulge. This phenomenon has important implications. The diameter at the equator is about 43 kilometers, 27 miles, greater than the diameter from pole to pole. This affects gravity. Gravity is slightly weaker at the equator because the centrifugal force partially counters the force of gravity. This means you weigh a little bit less at the equator than at the poles. Additionally, Earth's shape influences weather patterns. The Earth's slightly bulging equator contributes to the Coriolis effect, which causes large weather systems like hurricanes to rotate in opposite directions in the northern and southern hemispheres. It's an essential factor for understanding global circulation patterns, ocean currents, and even the formation of storms. This unique shape also impacts satellite orbits. Because the Earth is not a perfect sphere, satellites must be carefully placed into orbits, factoring in the equatorial bulge and varying gravitational forces. The study of this shape helps scientists to understand geophysical changes and even how the Earth's oceans distribute heat. 2. Earth's rotation is slowing down. Earth's rotation is gradually slowing down due to a process called tidal friction, which is caused by the Moon's gravitational pull. The Moon's gravity creates tidal bulges in Earth's oceans, and as the Earth spins, friction between the oceans and the Earth's surface slows down the rotation. Over millions of years, this has caused Earth's days to lengthen. In fact, one day on Earth was only 6 hours long about 4.5 billion years ago. Today, a day lasts 24 hours, but it's still increasing in length by about 1.7 milliseconds per century. This may seem like a small change, but it accumulates over long periods of time. As Earth's rotation slows, the Moon gradually moves away from Earth at a rate of about 3.8 centimeters, 1.5 inches, per year. In the distant future, the Earth and Moon will become tidally locked, meaning Earth will rotate at the same speed it orbits the Moon, and only one side of Earth will face the Moon, much like how the Moon always shows the same face to Earth. While the slowing of Earth's rotation doesn't have any immediate impacts on our lives, it demonstrates how Earth's dynamics are constantly shifting over time, highlighting the intricate relationship between the Earth and the Moon. 3. Earth's magnetic field protects us. Earth is surrounded by a magnetic field generated by the movement of molten metals in its outer core, primarily iron and nickel. This magnetic field, called the magnetosphere, acts as a protective shield against harmful solar radiation and cosmic rays. Without this shield, life on Earth would be exposed to harmful radiation, and our atmosphere could be stripped away by the solar wind. This magnetic field is essential for the protection of not just life on Earth, but also technology. Satellites and other spacebound equipment rely on Earth's magnetosphere to prevent radiation damage. Additionally, the magnetic field is responsible for the auroras, the spectacular light displays near the polar regions caused by solar winds interacting with Earth's magnetic field. Interestingly, Earth's magnetic field is constantly shifting. The magnetic poles reverse every 200,000 to 300,000 years in a process known as a geomagnetic reversal. This means the magnetic field flips, with the North Pole becoming the South Pole and vice versa. While these reversals don't seem to have catastrophic effects on Earth's lifeforms, they have significant implications for navigation systems and satellite operations. 4. Earth's tectonic plates are always moving. Earth's surface is divided into several massive tectonic plates that float atop the semi-fluid mantle below. These plates are constantly moving, driven by heat from the Earth's interior. Convection currents in the mantle push the plates in different directions. This movement leads to the formation of mountains, volcanoes, and earthquakes. The movement of tectonic plates is responsible for the formation of supercontinents. Around 200 million years ago, the continents were part of a giant landmass called Pangaea. Over time, Pangaea split into the continents we recognize today. The plates are still moving, and new landforms are constantly created. For instance, the Himalayas were formed by the collision of the Indian plate with the Eurasian plate. The mountains continue to rise at a rate of about 5 millimeters per year. Tectonic movements also play a crucial role in the carbon cycle. When tectonic plates move, carbon is carried down into the mantle, where it can be stored for millions of years. This process helps regulate carbon dioxide levels in the atmosphere, which in turn influences the global climate. While plate tectonics are responsible for creating the beautiful landscapes we see today, they also lead to natural disasters like earthquakes and volcanic eruptions. The Ring of Fire, a region around the Pacific Ocean, is notorious for its high level of tectonic activity, making it an area prone to earthquakes and volcanic eruptions. 5. Earth is the only known planet to support life. Despite the discovery of thousands of exoplanets in recent years, Earth remains the only planet known to support life. But what makes Earth so special? Several unique factors make Earth the perfect environment for life to thrive. First, Earth resides in the habitable zone of our Sun, often called the Goldilocks zone, where conditions are just right for liquid water to exist. Liquid water is essential for all known forms of life. Earth has vast oceans, rivers, and lakes, providing abundant water for plants, animals, and humans alike. Earth's atmosphere is another crucial factor. It contains the perfect mix of gases to support life, including oxygen for animals and carbon dioxide for plants. It also helps maintain a stable temperature, preventing extreme temperature fluctuations that could make the planet inhospitable. The planet's magnetic field further shields life from the harsh conditions of space. It protects the atmosphere from being stripped away by solar winds, ensuring that Earth can retain the gases necessary for life. Additionally, Earth's plate tectonics play a role in regulating the planet's carbon cycle, keeping the climate stable over millions of years. Perhaps most importantly, Earth's biodiversity is unparalleled. From the depths of the oceans to the highest mountain peaks, life on Earth exists in an incredible range of environments. Scientists continue to study Earth's ecosystems to better understand how life evolved and what conditions are necessary to sustain it. While astronomers are constantly searching for signs of life elsewhere in the universe, Earth's combination of liquid water, a stable climate, a protective magnetic field, and a rich array of ecosystems makes it an extraordinarily rare and precious planet.